guys, welcome back to my channel. So now we are going to start chapter number 1 part 2. Let's consider what topics we are going to cover in this video. First, balancing chemical equation. Second, types of chemical reactions. Third, corrosion. Fourth and last, rancidity. So let's start the video with first topic, balancing chemical equation. So why we need to balance a chemical equation? Because of law of conservation of mass. Very important question in 1 marks, that why we need to balance a chemical equation. So the answer is so simple, because of law of conservation of mass. What this law says, that in a chemical reaction, mass can neither be created nor be destroyed. So this we have studied earlier too, last class. So now the topic comes how to balance a chemical equation. So to balance a chemical equation, first of all, count number of atoms of each element on the both side of arrow. Please note the word I am saying atoms here. Actually, these are not atoms, but these are moles. I will clear this. Let's see how. So here we see that I have taken example of activity 1.1 reaction equation. That is Mg plus O2 gives us MgO. Here when we burn magnesium, it gives us magnesium oxide. So now this equation is not balanced. So to balance this equation, first let us consider the reactants, the moles of reactants and the products of reactants. So see, on the reactant side, Mg is for 1 mole. On the product side, Mg is again 1 mole. Means till now Mg is balanced. So in oxygen, on the reactant side, oxygen is 2 moles, but on the product side it is 1 mole. So are they balanced? No, they are not balanced. See, we need to balance it. Mg is already balanced, whereas we have to balance oxygen. For balancing, we will put 2 on product side. How we will put 2 on the product side? Let's see. Please see that we will not balance the equation like this. This equation is given to us, Mg plus O2 gives us MgO. We will not put 2 over here to balance oxygen. No, we will write Mg plus O2 gives us 2 MgO. See guys, this is the rule, that we will not put in between. See, like this. This is wrong, but this is right. So let's see. So guys, what we will do is that we will, and I'm going to write full equation. Mg plus O2 gives MgO. So now for balancing it, what we will do, I will count the number of moles present in this. Mg is 1, O2 is 2, but O is 1 over there. So I am going to put 2 over here. Where I have put 2, let me show you. So 2 we are going to put over here. Now what we will see that oxygen is balanced. Oxygen is balanced, but Mg is not balanced. As here Mg is now 2 and Mg here is 1. So we have to balance it again. So for balancing it again, what we will do? We will simply write here 2. Now it's perfectly balanced. Please see, it's perfectly balanced. See, here Mg is 2, here Mg is 2. This is product side, this is reactant side. Here oxygen is 2, here also oxygen is 2. This 2 we have to multiply. 2 into Mg, 2 into oxygen, like this. So it's perfectly balanced. Here also 2, here also 2. So it's balanced now. So I have not write balanced equation here. I am balancing it here. So now 2 Mg plus O2 gives us 2 MgO. This is a perfectly balanced equation. Balancing was really very easy. Just for explaining it has gone long, but it will not take that much time to balance by ourselves. So let's see what's next. Next is types of chemical reactions. Very easy topic. Don't worry about this topic. This is not going to make such a difficulty. So first of all, let's come on combination reaction. What is a combination reaction? Then we will go decomposition reactions. First, let's consider the types of these chemical reactions. The types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, redox reaction. One thing I want to clear you that this is reverse. Decomposition reaction is opposite of combination reaction. Double displacement is half similar to displacement reaction, but we can say that it is also opposite of displacement reaction. Redox reaction is new topic and interesting topic. So let's see what is next. So next is combination reaction, our first type of chemical reaction. So those reactions in which two elements or two compounds combine together to give a single product is called as combination reaction. So I would like to write formula of combination reactions, the simple formula. We have to not do any calculation, but just the basic formula is that A plus B gives us AB. This was the simple formula that we are getting here, is that A plus B, when A reacts with B, it gives us AB. So for example, I have taken of hydrogen gas. When react with chlorine gas, it gives us hydrochloric acid, HCl, which is present in our stomach. So here A and Cl are reacting and producing HCl, hydrochloric acid. Balanced form of this reaction is H2 plus Cl2 gives us 2HCl. Please note, very important, that balancing is really very important. Really very important, otherwise it will cut your half or 1 marks in exam. So please balance this. Okay. So let's do next part. Decomposition reaction. Combination reaction was that only. In book we are given, I think, 2 or many types of examples. Like first example is calcium oxide when reacts with water gives us CaOH2. Calcium hydroxide. So here see, CaO is a quicklime. So when we put quicklime in the water, it start reacting and gives us CaOH2, that is calcium hydroxide or slaked lime. While this reaction is taking place, we will feel heat on the beaker in which this reaction is going on. Okay, this is activity 1.4. Then next here is of burning coal. Burning, wherever you see burning, you have to add O2. Please learn this, that wherever you find burning, you have to add O2 in the reactant side. So here coal is burning. Coal is made up of carbon. It is the symbol of coal also, carbon symbol. So C plus O2 gives us CO2. C plus O2 gives us CO2. Then formation of water, H2 gas when react with O2 gas, I mean oxygen in gas, then gives us water. Then there is burning of natural gas, CH4, that is methane. CH4, that is methane. When react with oxygen, when we burn it, it produces CO2 plus H2O. So then there is next process of given of glucose. In glucose we see that C6H12O6 plus 6CO2 gives us 6CO2 plus H6H2O plus energy. These examples are of exothermic reactions actually. These are of exothermic. Exo means to release, endo means to intake. So let's come to decomposition reaction. In decomposition reaction, first of all, what we will see is that these reactions are those reactions in which a single substance, a single compound substance breaks down to give two or more simpler substances. Again, I am repeating that those reactions in which a single substance break down to give two or more simpler substances. Now, types of decomposition reactions are: first, thermal decomposition reaction; second, electrical, also called electrolysis; then photolytic decomposition reaction. So let me tell you one thing. That symbol of heat. Symbol of heat is heat. Is a triangle. Symbol of heat is triangle. Symbol of precipitate reaction is this. This is PPT. And this symbol is of gaseous state. this represent gas, this represent ppt, this represent heat. So these are the 4 types of reactions in decomposition reaction. Let's see what are these reactions. First, thermal decomposition reaction. In this reaction, heat is provided to the reactant. Of course, it is thermal decomposition reaction, so we are going to heat the substance which we are which is reacting. So ZnCO3, zinc carbonate, when it is provided heat, gives us ZnO plus CO2, zinc oxide plus CO2, carbon dioxide. And the example given in our book is PbNO3 whole 2, that is lead nitrate, when heated gives us PbO plus nitrogen oxide and oxygen. PbO here is lead oxide. One thing to note, this question has came in our exams, that which gas produces brown fumes or yellow fumes, brown or yellow fumes. The gas is N2 gas. If you see here that I have not balanced this equation, so you guys have to balance this equation and answer me in the comment box. Okay, so please answer me this in the comment box. I am not balancing this equation. The balanced form is given in your book also. Let me make the symbol here of heat. Here it is provided with heat. It is also provided with heat. So they both are provided with heat. Next is electrolysis. What is electrolysis? Electro words gives us meaning that it is related to electricity, current. So the question in this case is that if you see the diagram in your book, given in your book, see here, if you note, here if you guys note that at the cathode side you will find that empty space on the tubes. On cathode side it is more, but on anode side it is less. So why is it? So for this we have to make a reaction. So we will make a reaction over here. Equation we will make. So let's make us an equation, and the equation is H2 O. H2O is here present in it. When it is provided with current, electricity, it forms H plus ion plus OH negative ions. OH is always negative and H is always positive. So H plus ion goes on to cathode. They goes on cathode and forms H2 gas. Whereas OH ion, OH negative ion, these are plus ion, these are negative ions, goes to anode and they forms O2. Okay, they forms O2. So let's see what is the problem here. That H2O, what we given it? Electricity, a shock we given it to. So it formed H plus ion and OH negative ions. Let's H is not coming here. Oh, it's negative ions. So what it formed? H2 gas and O2 gas. Why? See here. See here, O2 is forming, and at cathode H2 is forming. So H2O, when electricity is provided, gives us H2 on cathode plus O2 at anode. Now we will balance it. 2 over here and 2 over here. It's balanced now. Here oxygen is 2, also there. Here therefore we have to multiply this 2 to this 2. So total 4. Again this is 4. So this is also balanced now. Now let's study next type, that is photolytic decomposition reaction. Only two reactions are present in this topic, that is AgCl in presence of sunlight gives us Ag plus Cl2. Silver chloride when kept in sunlight gives us silver plus Cl2, chloride gas. Here also reaction is taking place. In this reaction, we will provide the reactant with sunlight, and in the presence of sunlight, they react and forms a new product. So 2AgBr, silver bromide gives us Ag, silver. Also they gives us bromine. Here 2. Please note it is 2 over here. In the book it is given correctly. So 2AgBr when in presence of sunlight gives us Ag plus Br2. 2Ag plus Br2. Let me tell you the symbol of sunlight too. That is H nu. H and nu. This is the symbol of sunlight. So these reactions are used in black and white photography. These above two means AgBr and AgCl reactions are used in black and white photography. The reaction in which energy is absorbed are known as endothermic reactions. Earlier in combination reaction we talked about exothermic because it was releasing heat. Now it is taking energy in the form of sunlight, in the form of electricity, in the form of heat. So we will call it endothermic reactions. Okay, let's do next part. Displacement reaction. Those reactions in which more reactive metal displaces less reactive metal from its salt solution is called सिंगल डिस्प्लेसमेंट रिएक्शन. नहीं आया समझ? लेट मी एक्सप्लेन. जब एक मोर रिएक्टिव मेटल एक कम रिएक्टिव मेटल को अलग दूर भगा देता है उसके कंपाउंड से, तो उसे हम डिस्प्लेसमेंट रिएक्शन कहते हैं. तभी तो इसका नाम डिस्प्लेसमेंट है, यानी कि अपनी प्लेस से हटा दिया गया. Now, how we will know that what is less reactive or what is more reactive? So for this, in the chapter 3rd, we are having a reacting table in which first highly reactive metals and then in last most least reactive metals are there. Very easy way of learning the table I am having, and I am going to tell that after the completion of chapter or in the 3rd chapter only. When I will make the video of 3rd chapter, in that only I am going to tell you about how to learn that table easily and funnily too. So very easy to learn the table. Let's come on our example. When ZnCl when Zn react with HCl, it replaces. Zn is more reactive than hydrogen. I forgot to place the reacting table in this PPT. So please check on page number 45. On page number 45, activity series or reactivity series is given. We will see that hydrogen is less reactive than zinc. See, zinc is on third, up on third. H से वो 3 ऊपर है जिंक. तो जिंक क्या है? जिंक एक हाई रिएक्टिव मेटल है हाइड्रोजन से. तो उसने क्या किया, धक्के मार के निकाल दिया हाइड्रोजन को और खुद वहां का राजा बन के बैठ गया. तो यहाँ पर क्या हुआ, Zn प्लस HCl जब रिएक्ट हुए तो हमें क्या मिला, ZnCl2. I forgot to balance again. So H2 और H2 देखो यहाँ पर H कितना है 2, Cl कितना है 2, जिंक कितना है 1 और Cl यहाँ पर है 1 और ये 1. बैलेंस्ड क्या नहीं है, Cl2 और H2. Easiest way is that put here 2. This is balanced now. This reaction is balanced now. Now when I put here 2, this reaction is balanced now. Let's move to next reaction, that is double displacement reaction. Very easy reaction. Now such reactions in which there is an exchange of ions between the reactants are called double displacement reaction, or those reactions in which two atoms changes their place. Okay, I forgot to remove it. Or those reaction in which two atoms or two group. Please study it differently. This or I have to place here. This sentence is connected. So those reactions in which two atoms or two group displaces each other are known as double displacement reaction. First example is neutralization reaction. Neutralization is to do neutral, मीन्स ज़्यादा एसिड ना हो ना ही बेसिक हो. तो जब दोनों मिक्स हो जाते हैं, HCl एक एसिड है, NaOH एक स्ट्रॉन्ग बेसिक है, जब ये दोनों रिएक्ट होंगे तो हमें मिलेगा NaCl. NaCl इज कॉमन सॉल्ट दैट वी यूज एट होम्स, बट ये थोड़ा प्योरीफाइड फॉर्म है, इसके अंदर आयोडीन वगैरह सब कुछ पता नहीं कुछ मिला के हमें दिया होता है, तो हम इसे सिंपल यूज़ नहीं कर सकते. बट ये कॉमन सॉल्ट है जो हम अपने घर में यूज़ करते हैं. और H2O ये तो हम हर जगह यूज़ करते हैं. तो ये होगी न्यूट्रलाइज, क्योंकि ये बन चुकी है अब एक न्यूट्रलाइज्ड फॉर्म ऑफ HCl plus NaOH. So neutralization is a example of double displacement reaction. Then second is precipitation reaction. I was doing PPT precipitation reaction. Here come PPT. This is PPT. BaSO4. Barium sulfate is PPT. This is PPT. This becomes precipitate. This is the insoluble part. This settles down. So BaCl2 plus Na2SO4 when reacts together, they form BaSO4 and NaCl. BaSO4 is PPT. Again, forgot to balance them. So let me balance them. Here 2. Now it's balanced, perfectly balanced. Now BaCl2 plus Na2SO4 gives us BaSO4 plus 2NaCl. Let's start next. Very interesting topic. Very interesting topic is redox reaction. Really interesting. If you want to find the definition of decomposition reaction, you will find it on 12 number page on the where recall activity 1.2 is written. Above it, that such reaction in which there is an exchange of ions. This is the definition of decomposition reaction. So now redox reaction. What is redox reaction? Let's see. Redox. I have specially written this in the chart. See, redox, where red is written. Here red denotes to reduction. This red, and this oxy denotes to oxidation. In this chapter, reduction and oxidation means is the classical method. In the book it is not given what is classical method or what is modern method, but you will note that somewhere. Let me explain first, then I will tell what you have to note. Let's do next. So first, method of redox reaction. This is classical method. In this method, when H2 is added, it is known as reduction reaction, and when O2 is added, it is known as oxidation reaction. Very simple, no? When H2 is added, it is reduction. When O2 is added, it is oxidation. It is not necessary कि वो O2 हो या H2 ही हो. सिंपल कहना था कि हाइड्रोजन या फिर ऑक्सीजन. सिंपल हाइड्रोजन ऑक्सीजन अगर ऐड होंगे तो भी वो रिडक्शन और ऑक्सीडेशन कहलाएंगे. इसका एक सिंपल सा एग्जांपल है अपनी बुक में. दूसरी जो इक्वेशन दी हुई है, दैट इज CuO plus H2. That is CuO plus H2 gives us heat. When we give them heat, they produces Cu plus H2O. This is the reaction. See, this is the reaction. When CuO is added, in this CuO plus H2 is added and we provide them heat, they gives us Cu plus H2O. Now I am telling about redox reaction. So let me tell you where oxidation and reduction is. This is a simple method, so you all can guess what is where oxidation is happening and where reduction is happening. I think you all have guessed. So what I said, where oxidation where oxygen is added, it is called reduction reaction. Oxidation reaction. So here O2 is added. Please note, this oxygen is added with H2 and gives us H2O. So what is this? Oxidation reaction. But Cu removes with Cu, then it is reduction. Now you all are having doubts that how Cu is getting reduced because H2 is not added in it. Please note, in Cu, please note, this is reduction side, this is oxidation side. Okay, addition of O2 and addition of H2 नहीं, simple H, hydrogen. First point. Second point, removal of oxygen and removal of removal of हाइड्रोजन एंड रिमूवल ऑफ ऑक्सीजन, एक दूसरे का उल्टा। ये देखो रिडक्शन में क्या हो रहा था, हाइड्रोजन ऐड हो रहा था, और ऑक्सीडेशन में क्या हो रहा था, ऑक्सीजन ऐड हो रहा था। बट दूसरे स्टेप में क्या हुआ, एकदम उल्टा ना। अब ऑक्सीडेशन में क्या हो रहा है, हाइड्रोजन रिमूव हो रहा है, और रिडक्शन में ऑक्सीजन रिमूवल है हो रहा है। ऑक्सीडेशन में हाइड्रोजन इज रिमूविंग एंड रिडक्शन में ऑक्सीजन इज रिमूविंग। सो ये एक दूसरे का उल्टा भी माना जाएगा, सिर्फ एडिशन नहीं चलेगा। नेक्स्ट थिंग, लेट्स कम टू नेक्स्ट मेथड, दैट इज सेकेंड मेथड ऑफ redox reaction. Simply it is modern method. This is modern method. So in this method we will learn two things. Actually we are not going to learn this Leo, Ger, no. Actually these are attributes used by me to learn this easily, told by my teacher. In this Leo stands for loss of electron is oxidation. GER, gain of electron is reduction. Here Le stands for loss of electrons and O stands for oxidation. Here GE stands for gain of electron and R stands for reduction. Very easy to learn. Please note कि हम ऐसे करेंगे, ये सिंपल से एट्रीब्यूट्स याद करेंगे और ऑक्सीडेशन रिडॉक्स रिएक्शन याद हो गई हमें. So Leo is losing of electron is called oxidation reaction, whereas GER if gaining of electrons, which is reduction reaction. Note one thing, metal always shows oxidation reaction, they never shows reduction reactions. When an element is alone, now charges on this are, when an element is alone there is no charge upon it, it is neutral. Here if there is bond between same element, like when it is in gaseous form, example H2, H and H is having bond like this, then it is also having zero charge. Substance which undergo reduction, important thing, question comes on this. जो चीज खुद ही रिडक्शन पे जा रही हो उसे हम ऑक्सीडेशन एजेंट बोलेंगे. फॉर एग्जाम्पल जो हमने अभी एग्जाम्पल लिया था, दैट इज CuO plus H2 when provided heat gives us Cu plus H2O. Here what is going on, oxidation is this oxidation and this is going on reduction. One thing, this is going on oxidation, H2 is going on oxidation, but it is reducing agent. This is going on reduction, so it is oxidation agent. So now in wordings, please see, substances which undergo reduction itself called oxidation agent, and substances which undergo oxidation itself are called reduction agent. Okay, reducing agent. Okay, so these are the two main things. You will get questions to find oxidizing agent, reduction agent, like this. So okay, you will get these questions, you have to solve them. Very easy, they are not so difficult. Corrosion of iron, not given in the book but present in the third chapter and it's also important because question can come. So I'm teaching this in this chapter because third chapter is so long. Please see, corrosion of iron is called cancer of iron. Why? Because all iron metal disappears in form of flakes. Now this question has came, formula of rust. I have tackled it 3 times in my exams. So Fe2O3 dot XH2O. What is XH2O? What is XH2O? It is moisture. We don't know the amount of water present in moisture. This is moisture. And for Fe, when Fe reacts with O2, when Fe reacts with O2 plus moisture, it forms rust. And to save the iron from rust, we will go to galvanization method. We can go for painting, for oiling, greasing, many other methods are there. So in this method, galvanization, what is galvanization is only see that in this method coating of zinc is done on iron. Please note, coating of zinc only on iron only is known as galvanization. We cannot use galvanization term for any other metals or in the place of zinc. Okay, when Fe react with steam, we only get Fe3O4. We only get Fe3O4. Now corrosion of aluminium. Spelling mistake. This is beneficial. Please correct it. It is beneficial. It is also known as beneficial corrosion of aluminium because aluminium oxide is sticky in nature. It's fixed to the surface of aluminium very strongly and does not allow fresh aluminium layer to come in contact with air. So ये सेव कर लेता है हमारे एल्यूमिनियम को. तो हम जब भी एल्यूमिनियम को यूज़ करेंगे, मतलब जब हमें कोई नया मेटल बनाना, नया कुछ एलिमेंट बनाना हो कोई, तो हम क्या करेंगे, जो ऑक्साइड है उसे उतारेंगे. वैसे तो ये बहुत स्टिकी होती है और प्रोटेक्ट भी करती है, तो हमें इसे उतारने की ज़रूरत नहीं होती, बट इसकी मोटी परत हम उसके ऊपर चढ़ा देंगे. वो फैक्ट्रीज उनके अंदर काम होता है, इंडस्ट्रीज वगैरह के अंदर, तो उसे चढ़ा के और फिर हमें उसे सेल कर देंगे, उसके ऊपर पेंट कर देंगे. That's so that it looks shiny and beautiful. Now let's do next. Now what is next? Corrosion of copper. Copper is very easy. How I learned that when corrosion of copper comes, कॉपर तो होगा ही उसके अंदर परमानेंटली होगा, और कॉपर के साथ हम क्या करेंगे, ऐड कर देंगे ऑक्सीजन. मतलब जो एक एयर के अंदर प्रेजेंट होती है चीज़ें वही O2 प्रेजेंट होता है. हमने मॉइस्चर नहीं लिखा, बट वाटर प्रेजेंट होता है हवा के अंदर और CO2. तो CO को जब हमने हवा के साथ रिएक्ट कराया तो हमें ये मिल गया CO3 डॉट CuOH2. इतना बड़ा फॉर्मूला याद करना पड़ेगा. ये ग्रीन कलर का होता है. ये क्वेश्चन आया कि ये कौन से कलर का होता है, कोरोजन के बाद कैसा हो जाता है, तो ये ग्रीन कलर का होता है. So let's see what's next. Corrosion of silver. Silver reacts with hydrogen sulfide. Silver only reacts with hydrogen sulfide. H2S formula of hydrogen sulfide So when 2 moles of silver reacts with hydrogen sulfide gives us Ag plus Ag2S plus H2. Please note, Ag2S is black in color and acidic, as Ag is a metal. So to remove this, we will use toothpaste powder. Okay. Next, rancidity. What is rancidity? Please, let's check. The oil we use, the regular oil we use in our daily life, have double bonds of carbon. C is equal to C. Now what are these? Let me tell you. One carbon have valency 4. So like this. It is making double bond with another carbon. So 2 valencies are used here. Now 2 valencies are left. So they will connect with other elements present in the oil. So when we cook oil, the bonds get loosen up. सो ये जो डबल बॉन्ड्स है ये लूज हो जाते हैं और इनका ऑक्सीडेशन आसानी से हो जाता है, तो ये खराब हो जाता है। इनके अंदर अगर हम कुछ देर इन्हें ऐसे ही कुक करके छोड़ दें तेल को तो वो खराब हो जाता है। तो उसे बचाने के लिए हम क्या कर सकते हैं? फर्स्ट स्टेप इज रेफ्रिजरेट, सेकंड एयर टाइट कंटेनर। उसे एयर टाइट कंटेनर के अंदर पैक करके रख सकते हैं ताकि वो ऑक्सीजन या कोई ऐसे रिएक्टिंग गैस के साथ रिएक्ट ना कर जाए। या फिर जो हम चिप्स वगैरह डेली लाइफ में खाते हैं उसके अंदर क्या होता है, जैसे ही हम उसको खोलते हैं तो उसके अंदर चिप्स कम और गैस ज़्यादा होती है। तो वो गैस क्या होती है? वो नाइट्रोजन गैस होती है। नाइट्रोजन गैस एक नॉन रिएक्टिव गैस है, तो वो हम उन पैकेट्स के अंदर फिल करके रखते हैं। तो इसके अंदर नाइट्रोजन गैस फिल अप होती है, या हम इसके अंदर इनर्ट गैस भर देते हैं। इनर्ट गैस कौन सी होती है? जिनके पास ट्रिपल बॉन्ड बने हो। एन की वैलेंसी क्या होती है? एन की वैलेंसी होती है 3, तो एन की तीनों वैलेंसी एन के साथ ही लग गई, इसकी भी 3, इसकी भी 3। एक्चुअली ये जो लाइन होती है ना, ये होते हैं ऐसे डॉट्स जो हम बनाते हैं। हमने पिछली बार ये शायद किया था। तो इनर्ट गैस होते हैं एन ट्रिपल बॉन्ड विद एन, विच इज लीस्ट रिएक्टिव एज इट हैज ट्रिपल बॉन्ड। तो ये किसी के साथ रिएक्ट नहीं करेगा क्योंकि ये वो न्यूट्रल हो गया ना अब। या फिर हम यूज करेंगे एंटीऑक्सीडेंट्स। कौन से? BHA। BHA इसका एट्रीब्यूट, दिस इज ब्यूटाइलेटेड हाइड्रोक्सी एनिसोल और ब्यूटाइलेटेड हाइड्रोक्सी टोलुइन। या हम कैटलिस्ट यूज करेंगे जैसे पैलेडियम, निकल, प्लेटिनियम। कैटलिस्ट किस लिए यूज होते हैं? किसी भी रिएक्शन को स्पीड या स्लो करने में काम आते हैं लेबोरेटरीज के अंदर या किसी भी चीज़ों के अंदर। तो ये था हमारा टॉपिक। थैंक यू।